hydrostatic force
等一下 before 我们走看安特。
rho g
看你怎么？看得赢吗？
好，假不要看。
area.
哦，东西。
Alright, this is the equation. Hydrostatic force is given by rho times g times hc times area. Okay? This indicates the projected area. Okay? This is the equation. You have to remember. Alright. Hc indicates the distance from the water surface to the centroid of the object. So this is called, this is the object, centroid is here. So distance from the water surface to the centroid is called HC. Or some book people are writing YC, also same thing. Alright? And another point is called center of pressure, CP. Center of pressure at which the hydrostatic force is found. Okay? And the distance from the water surface to the center of pressure is defined by YR. Okay? And YR is calculated by this equation. YC plus IXC, first moment of inertia with respect to this object, right? And divided by YC times area. So we are using this equation to calculate the distance from the water surface to the center of pressure of any object. It may be any shape, right? It may be rectangular shape, triangular shape, circular shape, anything. Okay? And HC and YC are same. The distance from the water surface to the centroid or center of gravity is YC.
Chicken bone.
Okay? So YR is calculated by this equation. So today we are using two equations. Number one is hydrostatic force, rho g HCA, this one. Or if you write FR gamma YCA, same thing. Gamma means rho g, YC HC A, or if you want to write rho g YCA, also okay. No problem. Or this is one equation, and number two is this one. And IXC is the moment of inertia, and the formulation will be given to you, so you do not need to worry. Will be given. Done. So you see, these are the shape of the object. Some are rectangular shape. So you see, this is called a centroid, right? And if I draw one line, that means it is rotating in x-axis. So in that case, first moment of inertia IXC is equivalent to 1 over 12 BAQ. Remember, in that case, this axis, that means y-axis indicates A and x-axis indicates B, because it is rotating with respect to B, this way. On the other hand, if the object is circular shape, in that case, in this axis, it is rotating, so IXC and IYC is pi r power 4 by 4. Area is pi r square. So you have to know this. For the semicircular shape, this is the rotating axis. So IXC 0.1098 r power 4, and area is pi r square by 2, and the distance, right, y is 4r by 3 pi. Alright? This is HC or YC. So YC for semicircular case from here, right? From here to here. This is YC or HC, same thing. And this value is equivalent to 4r by 3 pi. For rectangular shape, this is the, we assume this is the distance from here to here is HC or YC. This value is equivalent to A by 2. Okay? Similarly, for triangular shape, you see, so this is the fluid surface, so this indicates HC, A by 3. For quarter circle, HC is 4r by 3 pi, same in both axes, right? Okay, so you have to use that. No need to memorize all the equations, and this chart will be given to you. You can use it. Okay, so first question is related to the gate. A gate with the shape. So this is the gate, not this one. This indicates the water surface. So this indicates the surface of the water. Okay? And this indicates the gate. You take a look. The green part. This indicates the gate. And the black one indicates the shaft. Okay? If you look in this view, you can see the gate is something like this. This portion is rectangular shape. Alright, this is a rectangular shape, and that portion is semicircular shape. Is the blue. Alright, so this is the understanding. If you look at this portion is something like this, and that one is something like this, and this indicates the shaft. Like this. So now the question is, determine the net moment about the shaft. They tell you have to calculate the net moment about the shaft. So what is the moment? Moment is defined by force times distance. We know, right? So moment is, M is moment, is equivalent to F is force times distance. I put here D, for example. Okay? So my question is now, so this is the water surface is here, right? No problem. This is the water surface. So from here to here is rectangular shape, from here to here is semicircular shape, right? So I can find its CG, no problem. I can find its CG, no problem. So I can find its center of pressure. I can find here the center of pressure, no problem. Right? So where force is found? At the center of pressure. Correct. So I need to locate the position of center of pressure at rectangular shape and the semicircular shape, right? So this indicates the center of pressure. I do not know at the moment the distance, but I can feel this indicates the center of pressure for rectangular shape object, and this is the center of pressure for semicircular object, right? So there are two forces. So one force is here, another force is here. Correct. This is Fr for the rectangular shape, and this one indicates Fr for the semicircular shape. Right? No problem. So what is the moment? So moment is found here, right? At the shaft. So I need to find the distance from the shaft to this CP, and from here to this point. Correct. Otherwise I cannot calculate. So you can see I can easily calculate the distance from shaft to the center of pressure and the shaft to the center of pressure, right? And this distance we assume y1, for example. This one I assume y2. Correct. No problem. Then I can see, oh, M becomes Fr are rectangular shape times y1 minus because this is like this, f are semicircular times y2. This is the moment, right? This one force clockwise, right? And there is another one anti-clock. So this one times this one minus this one times this one. If this is same direction, then both are positive. Alright, this is the concept. Now I am going to find the value, right? I need to find the value of which one is needed. Hydrostatic force for rectangular shape. Number 2, hydrostatic force for semicircular shape. Number 3 is y1. Number 4 is y2, right? The problem is solved. So now the question is how? These are the shape, right? Try to understand. What is this? This indicates the surface of the water. So water is here, right? Right. So if the water is at the top, you have to add the additional distance. Alright? So for example, if it is like this, so this is the water and whole shape is something like this, for example. Hole is something like this and water is here. Right? What happens? You have to add this distance, additional distance. Then you have to add from here to center of pressure. Alright? You have to add this additional distance. Okay? So now, you see, what is this? Center of gravity, right? This indicates the center of pressure of rectangular object. Similarly, this one indicates the center of gravity for semicircular, and this one indicates the center of pressure. So I can calculate the distance, right? YC1, I can find, right? What is the value of YC1? The distance from here to here, what is the number? 6. So this one definitely 3. From the rectangular object, you can see. No problem. So from here to here, yes, you have to find some number. Right? And from here to here is 6, from here to here is 6, from here to here is 3. Correct. Then I show you how I can get of the number. YC1 becomes, so this one is 6 by 2, right? Is 3. So that's why, what is YR1? Tell me, this one becomes, YR1 becomes, YR1 becomes YC1 plus IXC YC1 times area of rectangle. And IXC, you can get it from the picture or chart. Okay, 1/12 B AQ. B is 6, A is 6. Then you can get it. Alright. Now, okay, then I can write YC1 is 3, correct? Plus, what is the IXC? Tell me.
12.
IXC? 1/12 B AQ. Right, YC1 is 3. What is air? 6 times 6. Alright, so I get here 4 meter. I don't need, no problem. Then I can find what is YR? Y1. I need to find, right? The center of pressure is here, right? So I need to find Y1. So what is Y1? Correct, 6 minus YR1. Correct. So what is the Y1? y1 becomes, this y1 becomes 6 minus 4. Am I right? Correct. Now, so I am going to find yc2 because one center of pressure is here. Right? So this one is FR of rectangular shape. So what is the value of FR rectangular shape? Tell me. FR for rectangular shape. Correct. Rho G HC area, right? What is the rho C? Tell me. Rho G 9800. Last week I tell you HC is 3. Area is 6 times 6. Am I right? Correct. So this unit is Newton. And after calculation, I get 1060000, right? Divided by 1000, I get kilonewton. Pretty simple. So I get this value, I get y1. Done. Correct. So now I need to find the distance from here to here. I tell you, you have to measure from the water surface, not from here. Alright? From here to here. That means from yc2 becomes 6 plus the distance from here to here, right? Which is 4r by 3 pi. Alright? If you look at the picture, you can see the distance from here to here. 4r by 3 pi. 4 times r is 3, 3 times pi. Alright? So what is yc2? yc2 is the distance from surface of the water to the center of semicircle. That means 6 plus, so what is yc2? 6 plus 4 times 3 by 3 pi, which is, I get here 7. yc2 I get how much? yc2 I get 4r by 3 pi. What is the number? Tell me. 4r by 3 pi, 7.273. Right. Meter. Okay? So I can find yc2 from here to here. Done. Right? From here to here is yr2. I go to next slide. Otherwise, I do not have space here. Correct? So what is the y2? From here to here, right? So FR semicircle is found here. So I am coming later in the next slide. On red mark, I will calculate in the next slide. Semicircle, I am going to find, and yr2, this one. Okay? So what is the value of y2, right? y2 I need to find the distance from here to here. What is y2? yr2 minus 6. Very good. So yr2 is important. So I need to find, this one is becomes yr2 minus 6. So I need to find yr2. This is very important. Right? So I have to go next slide. Can I go? All right. You see, in the next slide, how to find? Correct. This is the the semicircle, this is the water surface, this indicates CG, remember, this indicates YC2, which is equivalent to 7.273. So this is the center of pressure. Right? Here is center of pressure, which is FR semicircle. And the distance from the surface of the water to that point is YR2, right? So what is this value? Tell me. F R for semicircle, rho G HC, right? For semicircle times area of semicircle, right? So what is the rho G? Rho G is 9800. What is HC of semicircle? This number 7.273. What is the area of semicircle? Pi r square by 2. It's here because I saw this one, pi r square by 2. Then what is pi? I know the pi from the calculator. R is 3 square by 2, and I get my answer. So this unit is Newton, right? So divided by 1000, you can get 1007.63 kilonewton. Done, right? So what is YR2? Tell me. YR2 is equivalent to YC2 plus IXC of semicircle, this guy, divided by YC2 times area of semicircle. So what is the value of YC2? Tell me. 7.273 plus IXC, how much? This one. 0.1098 times R to the power 4, right? Divided by YC2, 7.273 times
4.
area is pi r square by 2, right? That means I can write
Yeah.
10.1098
pi
R for 4.
Yeah.
r square by 2, right? And after summation I get YR2 becomes 7.36. Am I right? I get here 7.36. So this value is 7.36, right? And the distance from the water surface to this point, right, is 6. This is 6 meters. So what is the distance from center of pressure to shaft? This one, right? You remember, this is Y2 is equivalent to 7.36 minus 6, right? That means 1.36. Correct. Done. So my problem is solved. Correct? Done. Not very difficult. You have to work hard now. Correct? You have to do some step understanding. Okay? So now I get the number, right? So what is FR? Tell me, FR? 1060 times 2, right? Minus 1007.63 times 1.36. 749.62 kilonewton. Any question? Okay, if I give you one rectangle portion, you can solve it, right? If I give you this one, you can also solve it. No problem. You can find hydrostatic force. You know how to calculate y, the distance from the surface of water to the center of pressure for any object. You can find. Alright? This is the objectives of this question. Alright? I do not want to solve this. No need. Give you the solution already. Okay. This question. Calculate the horizontal and vertical hydrostatic forces acting on the dam. Okay, so this is the dam. Calculate the horizontal and vertical hydrostatic force. So what is the hydrostatic force? I should know, right? I do not know. At the moment, where is the hydrostatic forces as R, right? Acting on the dam as shown in this figure and hence determining the minimum coefficient of friction. Coefficient of friction is nu, is given, needed to prevent sliding. Specific weight of the concrete 23.6. Specific weight of the concrete is given 23.6. Right? Unit is kilonewton per meter cube. Alright? Please note that the dimension into the paper is 1 meter. That means this way, right? Is 1 meter. Right? This is 1 meter. In Z direction. So this one is 1 meter, 1 meter, 1 meter. And from here to here is 2 meter, here to here is 2 meter. From here to here is 5 meter. So where is the hydrostatic force? Tell me. Where you can see. What is the area? Surface area? Something like this, slanted like this, with the angle of theta. This angle, I do not know at the moment, but I am able to find this angle. Easy for me. So this is the surface area, right? But I have to find this surface area. Because this is the straight surface. This is not a curved surface. Straight surface, I look for the surface area. If it is curved, then you look for the horizontal and vertical. Two different issues. Okay? This is the straight line. So this surface is enough. Right? And the question is, where is the hydrostatic force? Definitely here, right? Correct. I tell you the distance from the surface of the water to this point, right? So from here to here. Right? What is the distance? 4 by 2, right? Distance is 4 by 2. So that means hydrostatic force is F is rho G Hc. Done. So I can easily calculate total hydrostatic force, which is easy for me. No problem, right? Fr becomes rho G Hc area. And area is definitely from here to here. The red area, I can show you this area. I have to find this area. Okay? This area means the distance from here to here times 1. Z axis is 1, right? 1 times the distance from here to here. This is the area, I know. So now, this angle I can find, no problem, right? Because I know the distance from here to here. If I draw a line, this is the 4, right? From here to here is 4. And from, if I draw one line from here to here, the distance from here to here is 5, correct? And from here to here is 4. Am I right? So I can write the distance from here to here, the blue, is 6 minus 2, 4 meter, and this one, right, from here to here is 5 meter. So what is the theta? I can easily find it, right? So I know tan theta is equivalent to 5 by 4, correct? Then I see theta becomes 51.3 degree. Done. Right? So I know the distance from here to here is it. How? Sin theta, right? The distance from here to here by here, right? Done. So I can see the distance from here to here. I assume this is O, this is B. So I can write 4. The distance from here to here is 4, right? So 4 by OB, correct, is equivalent to sine 51.3 degree. Then I can calculate OB, some number I get, correct? Okay, can I go next slide? Then you can see area OB I can get 5.415. So area becomes 5.125 meters square. Okay, 5.125 meters square. So what is the value of hydrostatic force? Tell me. Hydrostatic force, I get this number. How? Fr becomes rho G HC area, right? What is rho? 9800. What is HC? 4 by 2. By 2, right? 2 meters. What is the area? 5.125. Then I get 10046 kilo Newton. Right, done. So now they tell you have to find the hydrostatic force with respect to horizontal and vertical direction. So what is the hydrostatic force? The hydrostatic force is acted this way to prevent sliding. So it has two components because the angle is theta. This angle is theta, definitely this angle is theta by geometry. So this one is Fr sin theta, this one is Fr cos theta. Right? Then I can write, it has two components. Hydrostatic force is Fr, I put it blue. Green color is the net. This number. It has two components. One is the vertical component. This is Fv. And another one is horizontal component, Fh. So what is the value of Fh? Tell me. Fh becomes Fr sine, right? Fr sine 51.3. Then I get 78.4 kilometers. And what is the vertical component? Fr cos 51.3. I get 62.812 kilometers. And this is the answer. Okay? This is the part 1 complete. Second part, they tell you have to find the coefficient of friction. Then in that case, you have to do the force balance, both in x-axis and y-axis. Right? So W you have to find. What is this? Specific. What is this? Weight of the block. So this value is equivalent to rho g times volume. You know, right? So weight is mg. What is the value of m? Okay, I show you here first, and later I show you. What is this? M times g. What is m? Rho v. Correct. Then rho gv is equivalent to gamma times b. Gamma is given, right? 23.6 kilonewton per meter cube. Then gamma is given. What is the volume? What is the volume? Tell me. Area of the trapezium times the distance from the Z. Correct? Then, so V is easy for me now. Alright? So can I go next slide? Can I?
Yes, you can.
Okay. So FH I know. This one is given 78.4 kilonewton, 62.812 kilonewton is done. So it has two components. One is FB, sorry, this is FH. So this is FB. One is W. Okay. So this one I put all red color. Sorry. This one I put all red color. This is also red color. Frictional force. So in okay. So what is the force balance? Force balance tells me summation of force in x-axis is equivalent to 0. Then I can write FH minus frictional force is equivalent to 0, right? Then I can write FH. What is the value of FH? 78.4, right? Is equivalent to frictional force. Frictional force, this value is equivalent to frictional coefficient times nu, right? This is given to the question. Don't know. Should be given. Otherwise you cannot calculate. Should be given to you. It is not given here, but in the definite form. Okay? Nu times n. So this one I put equation number 1, right? So now in y direction I put all pink color. This one, and that one, right? Normal to the force. Then I can calculate. This way is positive. Then I can write W plus Fv is equivalent to n. Then I can write n becomes Fv. Fv plus, what is the W? Tell me. Half times the distance, right? 6 plus 2, am I right? 6 plus 2 times 5 times 1. Good. What is the Fv? Oh, this one times gamma, right? 23.6. What is the Fv? Is 62.812 plus all the numbers, and finally I get n becomes 534.812. So from equation, this is the kilonewton. From equation 1, I can find nu, right? Which is equivalent to 78.4 divided by 534.812 is equivalent to 0.147. This is the coefficient. Alright? Because why there is a normal force? Because weight is there, definitely there is another force on that area. Otherwise, it will not be balanced. Okay? And there is a frictional force here. Because it is sliding this direction. Because of water force that acts this direction, so there is a frictional effect, which prevents the dam sliding from the top to the water. Okay? Okay, question number 3. This is question number 3, right? A cylindrical tank with its horizontal axis has a diameter of 2 meters. Diameter from here to there is 2 meters, and the length is 4 meters. The ends of the tank are hemispherical. It's something like this. Ends of the tanks are hemispherical. It's something like this. Okay, something like this. A vertical 0.1 diameter pipe. Its diameter is 0.1. 0.1 meter diameter pipe is connected to the top of the tank. The tank and the pipe are filled with ethanol. Specific gravity of ethanol is 0.79 to the level of 1.5 meter above the top of the tank. That means the distance from here to here is 1.5. Determine the horizontal force of alcohol on one of the curved ends. Then you have to find the hydrostatic force. So hydrostatic force is found at the center of pressure. Okay? Center of pressure. So where is the center of gravity? Center of gravity is somewhere here, right? And this distance I know. From here to here, tell me the distance.
1.
From here to here is?
1.
What is the distance? 2 by 2?
1.
Here is 1, right? Right. And you have to calculate HC from here. This is the surface. Okay, this indicates HC is equivalent to 1.5 plus 2 by 2. That means 2.5 meter. Understand? Now the question is, what is the value of FR? FR is very easy to me now, right? Nothing new. Alright, so this one is something like this. This is looking hemispherical, is something like this. The cross-sectional area of this portion, right, is something like this. This is the cross-sectional area. What is the area? Pi r square or pi by 4 d square. Okay, what is the area? Area of this portion? Pi by 4 d square, right? Or I can write pi by 4 2 square, right? I can write, no problem. Alright. So this indicates the centroid, CG. And this one indicates center of pressure. The distance for the surface of the water to this point is called, this is YC actually, HC or YC. You can write, no problem. This one is YR. The distance from here to here, this distance, right, is YR minus YC. Okay, then they can tell you where is the location of the center of pressure. Then you can say, oh, the distance between the centroid and the center of pressure is this number. Okay? So FR we can easily calculate, right? No problem. What is the value of FR? Tell me. FR, specific gravity, right? Flow of water, G, HC, area. This area. And YR, YC plus IXC of this circle, okay? IXC of this circle, YC times area. Done. Question is solved. So now I show you the solution. This is the solution. Don't worry. Then this is the surface of the water. This indicates the centroid. Distance from the surface to the centroid is 1 meter. HC is 1.5 plus 1. Last time I wrote 2.5 meter. Okay. So area pi by 4 d square, right? This is the area. FR is rho G HCA. I get here this. How? FR becomes specific gravity times 9800 for water is 2.5 times area. area is pi by 4 times 4. Then I get specific gravity here is 0.79, right? Times 9800 times 2.5 times 5. Then I get here 60.8 kilonewton. This unit here is Newton. Alright? So this indicates the location of the center of pressure. Now this is YC, I know HC and YR. Right? What do you mean? You move this. Because you can see, right? Pi r equal to pi r square, I x c y r c, pi r cube by 4. So from there I can calculate YR, which is equivalent to YC is 2.5, right? 2.5 plus pi by 4 times R is 1. 1 to the power 4 divided by 4, right? And 2.5 times area. Pi by 4 d square. Then I can get YR 2.6 meter. Very simple. So now, thus, the question is thus, the resultant force has a magnitude of this value,
To
which
get
is
the rho
found
GH, you must
at
times
the distance
specific gravity
between the center of
No,
pressure
specific
and the center of
gravity
gravity
together.
of
density
1 meter.
times gravity.
And
you
it
must
is
times
found
the thing of
below the
water.
center of the tank.
Even though there's no water.
Okay? That means
No, because you
hydrostatic
have the
force is
density.
equivalent
They never give you
to
the density of the alcohol. They give you the
Right.
SG.
wall of the hemisphere.
Density,
Because
okay,
they-
density times gravity, right?
Because of the force balance,
SG
they
is
cancel each
divide.
other.
Divide 1000.
F wall
Yeah, that's what you
becomes
times back.
60.8 kilonewton.
Okay, later, I see.
Okay? Simple things. It's not new. This is here, right? If you put here. Okay, this question you should understand. There is a concept here. Try to understand. I take time to explain. Question: a canonical plug is placed. So this indicates a canonical plug is placed at the bottom of the tank, filled with liquid which has specific weight of 27 kilonewton per meter cube. Specific weight of the liquid 27 kilonewton per meter cube. The air space is pressurized to 50 kilopascal. So here the pressure is 50 kilopascal. All that point, the pressure is 50 kilopascal. Done. Determine the magnitude, direction and line of action of the force on the curved surface of the cone. Because this is not a straight line, right? This is a curve. This is something like this, curved surface. You have to find the force on the curved surface of the cone. Right? Then I can see this is the curved surface of the cone. At that point, right? What is the force? Correct. So now, what is the force? Tell me. Because what is the force here? The curved surface at that point. What is the force? This one plus this one, right? General law, weight. Force given with the air plus force given by the liquid is equivalent to the force that is acted on the cone and supported by the bottom of the cone. Then what I can do? I have to calculate this force. I have to calculate this force which is equivalent to Fc, I can write. Can I do this? Can I draw a dotted line with respect to this? Can I do this, right? So at the area, what is the force? Force given by air pressure is equivalent to pressure of air times the area from here to here. Correct? This is the force given by air. Then I can write easily, right? Then I can write, so force, this area, I have to calculate this area. We assume this is the cylindrical shape, so this is the diameter of this portion is D. That means if I draw a line, this is D, correct? So I can write, what is the force of air? Air force is equivalent to air pressure, pressure of air times area of this portion A, which is equivalent to area times pi by 4 d square, right? Done. When d square, now I do not know, correct? At the moment I do not know, but I can calculate. How? Then you can see this cone, this area, right? I put here. So we assume from here to here is 60 degree. So here theta becomes 30 degree, correct? Half. Half of 60 degree is 30. So from here to here is d by 2. And I know the distance from here to here, which is 1 meter. 1 meter, right? Then what I can do? Tan 30 is equivalent to d by 2 divided by 1, right? This divided by this. Then I can find value of d, which is 1.115. Correct, 1.155. Then I substitute the value here and I can find FA. Right? Because air pressure is 50 kilopascal. 50 kilopascal times pi by 4 times 1.155 square, I can get the number, which is air pressure. So air pressure is, I can write, right? So this one is, I can write 50 kilopascal times pi by 4 times 1.155 square. Air pressure is calculated. Separately, they can ask you what is the force given by the air. Then you have to calculate this area. Correct? Now, secondly, I need to calculate the weight of the liquid, right? In that area. Otherwise, correct? You have to calculate how. How to calculate the weight of the area?
Volume.
Correct. Rho of the liquid I know. Then I need to find the volume of that dump. Alright? So now I go to the next slide to show you the solution. Right? You can remember, right? What I do last time. Last time I do this one.
Okay.
You remember, right? And this one I make it bigger. Okay? And I am going to find the value of Fc, this one. So I can write, this is the force of air, right? F of air, right? I remember before I written. F of air plus W is equivalent to F of C by force balance. Alright, so what is the volume of the cone? This volume, right? The volume of the cone, I know pi by 3 r square h. Correct, r square h is 1. The distance from here to here is 1, right? 1. Then I can write pi by 3 r square h or d by 2 square h. I can get volume of the cone. Alright? Then, So what is the volume of the cone? Volume of the cone, I can get here, I can put the number now. Pi by 3 is 1.155 by 2 square times 1. I get here 0.35 meter cube. Roughly, okay? So, what is the volume of this portion? Or how you calculate the weight, W? W I calculate weight times this area, right? Weight becomes gamma times the volume of green portion, right? Am I right? This is the liquid. Then I can, that's why I write W becomes gamma, right? What is the gamma? W becomes gamma. What is the value of gamma? You remember? What is the question? 27 point something, right? What is the number? 27.27, right? This is 27. Correct. Times pi by 4, 1.155 square times 3 minus others, right? This is others. 0.35. Then I get here 27 times 2.793. Alright? So this is kilonewton I get. Alright? Then area of air pressure. I show you before, right? This number. Then under equilibrium condition, I can write Fc becomes air pressure times area times W. Then I can get Fc becomes air pressure, I can get 50 times pi by 4 times D, 1.155 square plus W is 27 times 2.793. After multiplication I get 127.8 kilonewton. This is the answer. This is the total amount of force that is acted here. Okay? Because it captures the weight, whole weight actually. This cone captures the whole weight of the air and the liquid. This is the vertical. Okay? Because cone is there, something like this. So that's why the vertical, why I do not consider the vertical force here. This one and that one. They cancel each other. Understand? One is this way, another is this way. Same value. So they cancel each other. Okay? They can tell you what is the horizontal force? Yes. 0. Because one is this way, one is that way. Because this is the curved surface. Alright? This is the understanding. If this is not curved, something like this, you have to calculate the horizontal also. Is the curve both way? If there is only one way, you have to calculate the horizontal also. Understand? If this is one, if this is, for example, I cut this, or I make it here straight line, then different. Alright, so today is up to now. So when is your quiz? Next week?
Yes.
Oh.
All the best.
就我看 video 我要看。